Hi everyone and welcome back. Today we will be talking about the Newton-Raphson method, which is a powerful technique used to find the roots of nonlinear equations. I will show you how to implement it in MATLAB step by step, and we will also walk through a practical example to understand how it works. So from the previous video, the Newton-Raphson method is an iterative process, which means that it generates successive approximations to the root of the function, and the basic idea is to start with an initial guess for the root. So here I have a simple example, actually a simple MATLAB code that implements the Newton-Raphson method. We start by defining the function f of x and its derivative. In this example, I'm using the function f of x like this, but you can replace it with any function you want to find the root of. Next, we choose an initial guess based on the Newton-Raphson formula, And the more accurate your initial guess, the faster the method will converge to the root. And the maximum number of the iterations and tolerance are set to avoid infinite loops and to stop once we get close enough to the root. So we define the function and its derivative, the initial guess, the maximum number of iterations, and the tolerance amount. So we should define the while loop and define the conditional statement, and the while loop performs until this logical condition satisfies. So unlike the for loop, we don't have the iteration index. So we define the iteration index like this, and inside the while loop we should define the parameters of the Newton-Raphson method, like the line 20. So we can write the conditional if loop to check the convergence condition per each iterations, and if this conditional statement is true, it breaks and get out of the while loop. So after all of this, if this condition is not true, the guess updates, and we should update the defined guess as the x1, and we should redefine the iteration number like this. So the while loop over, and we can display the result using the fprintf function and using the if loop. So we have the two situations. At first, actually the algorithm reaches to the root based on the defined conditions, and for the second one, as you can see here, the solution did not converge within the predefined iterations. So for the defined function and the other parameters, we define the while loop. So let's run the code. Now you can hear the root found, and it's almost 1.83 after 3 iterations. So if everything goes well, you will see that the root is found after a few iterations, and the method will print the root along with the number of iterations it took to converge. The root we find here approximately is 1.84 maybe, but you can try it with different functions and see how the method performs. And that's it. The Newton-Raphson method is a simple yet efficient way to find the roots of nonlinear equations, especially when you know the derivative of a function. Remember, the method works well for well-behaved functions, but if the function is complex, actually if the function is complex, you might need to choose a better initial guess or try another numerical techniques. Thanks for watching. Don't forget to like, share and subscribe if you found this helpful.